Okay, today is December 14th, 2011. We're on lesson 6.6. Our new formula today is still a sine wave. The variable in front of it is our A. And we're going to talk about how A affects it. And then we will eventually get into tomorrow putting all three of them together.
So today is just vertical flips and stretches.
Oh, actually, no, I lied. I lied. We're going to put them all together today. Okay? So, the first thing we're going to talk about is we're going to put a graph up here of a normal sine wave. And we're going to talk about how A is going to affect it as A changes. So, we're going to draw our original, which is our f at x is equal to sine x. Okay? Now, I want you guys to realize, I'm going to move this over a little. What number is technically in front of our sine x? 1. So that's actually our A variable. So in our normal equation, A is 1. Okay? So we start off, remember our key points, 0 and 0, 90 and 1, 180 and 0, 270 negative 1, 360 and 0. So we start off with our normal wave, and we can continue that pattern forwards and backwards. Okay? Okay, skip something here. Oh yeah, there you go, 360. So, we're going to draw the original one. Just like when we're transforming parabolas, it can be very helpful. It's 360, yeah. Everything's going up by increments of 90 degrees right now. Okay? So, there's our original one. Now, from our parabola rules, I want you guys to recognize if A is negative 1, what do we assume is going to happen? We have negative A. Okay? Anyone remember what A did with a parabola when it was negative? It flipped it upside down. Okay? So this is our A variable. So in this case, every point is going to flip. Okay? So, yeah, it's going to look the complete opposite of what it is. But there are some points that are going to be the same. Okay? What you're going to do is one way to flip it is to look at the y-axis. So 1, if I were to multiply that by negative 1, what would I get? Negative 1. So my new point at 90 is negative 1. Okay? What about negative 1 at 270? What is negative 1 times negative 1? Positive 1. So my new y-coordinate is positive 1. Now this is the one I want you guys to think about. At 180, we're at 0. What is 0 times negative 1? 0. So that coordinate still stays the exact same. Okay? So our 0 coordinates are still the exact same. It's our peaks and troughs that end up flipping upside and down. So it ends up kind of looking like a D&H chain here. So our red wave represents our new equation where A is negative 1. And I want to show you in the original one, I'm just going to rewrite it so you have it in there. Technically in the original one, our A value is 1. Okay, I want you guys to get used to that. Our H and K, which we were talking about yesterday, and we're going to talk about again today, H and K in the original one are 0. But our A variable in the original one is actually the number 1. Okay? And that number is actually telling us the amplitude of the wave. A is 1, that means it has an amplitude of 1. Okay? We're going to talk about when A is a different letter, and it's going to show you how it changes the amplitude of it. It essentially tells you what the amplitude is. Alright, so now we've talked about flips. We're going to talk about stretching the parabola this time. So this will be our blue graph. I'm going to give us the equation of f at x is equal to 3 sine x. Okay? So 3 sine x. It's the same idea. We take our A value and we're going to multiply it by the original y coordinates. So when y at 90 is 1, what is 1 times 3? 3. So our parabola now reaches up to 3. What about at 270? When it's negative 1 times 3, what would we get? negative 3. So we would be down at the y coordinate of negative 3. And again, I want you guys to think about this one. At 180, what is 0 times 3? 0. That coordinate stays the exact same. Again, I want you guys to realize that our zeros, we constantly pass through the same points, no matter what a is, as long as our h and our k are 0. Okay? So the idea to that is our 0 points are the exact same. Our peaks and troughs have been amplified or stretched by a factor of 3. So instead of going up 1, it goes all the way up to 3, comes down, goes all the way down to negative 3, comes up again, and reaches up to positive 3 again. And we continue the pattern. Negative 3, 0, positive 3, 0, negative 3. So we head down, up, and down. So you can see that our peaks and troughs have been stretched. Our coordinates where the y-axis was 0, it still passes through that 0 point. Okay? The reason for that is because the h and the k in all of these formulas I've given you are 0. There's been no transformations. Once we start to transform it, it's going to change quite a bit. And just for argument's sake, just so it looks like a nice pattern, we're going to give you one more question here. I'm going to give you f at x, exactly, when a is negative 3. Okay, so finally our green example here. Okay, we're going to do negative 3. It's the same idea. Remember, our black one is the original one. So we're multiplying our y coordinates, this time times negative 3. So what is 1 times negative 3? Negative 3. Negative 1 at 270 times negative 3 is positive 3. And what about 0? Still going to be 0. Okay? So again, I want you guys to look at this. This is essentially opposite of our blue graph, this green one. So it goes back down. This ends up being the opposite graph of our blue one before. It's been flipped on the x-axis. There we go. So we've shown you 4 different graphs there. What's very important is I want you to realize the black sine wave was the original. That's this function here. We then flipped it, which is the red function. All of the peaks and the troughs were the same. In our blue function, we stretched the black one by a factor of 3. And what's really important is I want you guys to realize this, is our amplitude. In our original one, the amplitude is essentially 1. The peak and the trough is 1, which is our A value. When our A value is 3, you're going to notice the amplitude, whoop, that was a little off. The amplitude is 3 in both of those. Now, when it becomes a negative number, does that change our amplitude to a negative? No, we're still dealing with the absolute value of it. So when A is negative 1, the amplitude is still 1. And when it's negative 3, the amplitude is still 3. We deal with positive numbers when talking about our amplitude. Okay? So if you get confused, remember I talked to you about how you could find the original sine wave by just pushing 90. So when x is 90, sine, our y value is 1. Well, if we're dealing with, say, our green one, our A value is negative 3, and I want to find the coordinate at positive 90, when x is positive 90, I put 90 sine times negative 3. My y value is then negative 3, which is exactly what we found in our green graph. So you can always plug these into the equation to find the coordinates on the graph. All right, our next example. We've already drawn the original wave. Okay. Our A value is a third. Okay, so I'm going to multiply my y values by a third in order to figure them out. So what is 1 times 1/3? 1/3. So instead of going all the way up to 1, it only goes a third of the way. Same when we're heading downwards. What is negative 1 times 1/3? Negative 1/3. So we only go a third of the way again. What about when we do 0 times a third? Still get 0. So those points are the exact same. Our peaks and troughs are much lower than before. So we have a graph, if you take a look at this. Sure. So if you look at our red function, because a is less than 1, so in this case, because our a value was a third, it's a number less than 1, it was compressed. It is lower than the normal peaks and troughs. And the peak and the trough for these here are actually, it goes to a height of 1/3, and it goes down 1/3. So if we were giving a domain and range, the range would be between positive 1/3 and negative 1/3, and our domain would still be XER. Okay? I'm gonna give you guys